Hello, and thank you for joining us today for our webinar entitled The New Low-Hanging Fruit. I'm Andy, Director of Product Marketing at AssetWorks, and I'll be your moderator today. Joining today is our presenter, Mr. Chad Currier, Director of Performance Solutions at BCS. For today's webinar, I'd like to go over just a few housekeeping items. First, all lines have been muted to prevent background noise. If you ask a question, you may submit your question using the Q&A box shown here on the right side of your screen. It is being recorded and will be made available for on-demand viewing on AssetWorks YouTube channel at a time. And all the housekeeping we have, so I'll turn things over to our presenter, Mr. Chad Currier. Chad, take it away.
Great, John. Appreciate everybody's time today, and appreciate AssetWorks for asking me to participate in the webinar. As I mentioned, I'm Chad Currier with BCS in Wichita, Kansas, and today we'll be talking about the new low-hanging fruit. Those of you on the call today are likely facing many mounting challenges in funding and aging infrastructure. So I hope that today some of the points that we cover and some of the things you see might help provide you and helping you to maybe overcome or at least mitigate some of those challenges. So one thing that I'll say to keep in mind is that in my experience, many of the issues that I team deal with clients to high operating costs or maybe a degrading infrastructure are rarely due to one single issue. You know, what we commonly find is that typically if you can piece together a number of different measures, that is a great way to try to address and help financially justify some of the needed upgrades. So we'll talk about that a little bit here today. Some of the topics we'll discuss, beginning with a little bit of background on myself, rounding out with some questions. Really, the meat of the discussion is going to be around what are the root of some of the challenges you might be facing. What do we mean by the old low-hanging fruit? And what are some possible ways to identify and take advantage of low-hanging fruit that are still likely present throughout some of your building portfolio? So myself, I started off as enlisted and commissioned officer in the Air Force, working in communications as a maintenance technician and then a program manager on nuclear weapon systems. And the Air Force had a program that I was fortunate enough to qualify. They helped me get my undergraduate degree at New Mexico State University, and then my graduate degree at the University of New Mexico. Like now when it's cold in Kansas, when I miss some of those New Mexico days. But after graduating from New Mexico, I went to work a couple of large Fortune 100 companies, did about 14 years between Johnson Controls and Siemens, worked in performance-based programs, a number of different markets ranging from K-12 to higher education, state government to commercial real estate as well. And you know, that's me well because I got to work with a lot of different clients. I believe in the peer type network, wanting to have someone that understands your type of business. If you were in education versus healthcare versus commercial real estate, those are very different markets. But after working with a lot of those clients, I'm also a proponent on learning best practices from each of those markets as well, because you never know if maybe the same engineer and architect that designed the hospital down the street is the one that did your science lab. Or maybe the one that did the art museum did your art building and music building on campus. So there may be some like systems and some like designs and some best practices that they might be doing that might work well within your portfolio as well. So that's helped me and some of our team and come up with some great ideas that we try to discuss with a number of our clients. But now I'm working as the Director of Performance Solutions for BCS in Wichita, Kansas. And our firm's been working over 30 years, helping our clients save energy and improve their buildings in a number of different ways. We have building technologies, mechanical equipment, as well as DDC and mechanical service. So great group of folks here. I'm very fortunate to be on the team. As far as some of the mounting accounting challenges that many of you on the phone are likely facing. One of them definitely comes in funding. When the team and I go out and we meet with clients, regardless of where it is, a lot of folks in your position have a good understanding of what issues are around your campus or portfolio. And really the reason that you haven't addressed those or really determine what the solutions are really come down to a resource issue, either a financial resource or a lack of members, not enough team, having to work with a lean workforce. So what you're facing are on the public side, state or federal government, where your executive team is reducing your budget. And then on the private side, a lot of revenues come from donors, and donors aren't always keen on providing dollars for operating or maintenance budgets. They always want them to go to the new building. So, what happens then is that your facilities and operations team start facing more deferred maintenance. That starts to snowball and pile up, and then as further cost cuts come, then you start reducing staff even more. So that starts to impact your overall deferred maintenance. And then after a while, after 2 or 3 years of that, having lean staff and putting out fires, you start to really lose a good grasp on what your true asset inventory and what your true condition of it is. And then, really lucky, then the owner will come through and will add more square footage to you, and you have more square footage to cover. But once you end up losing sight of what true condition of your inventory is, makes it tough to start to prioritize. When we're out meeting with some of our clients, one of the questions I always ask is, if you had a blank check and you could pick 4 things to do, what would those 4 things be? And then I get this inquisitive look and they say, where do I start? And then about 4 or 5 things that this is where I would go with it. That we start. We start with those particular things. So, we go to uncover some of these challenges. Asked online here, probably go route around lighting retrofits, variable frequency drives, and water conservation. Those are great upgrades. Pretty easy. What currently costs you to operate something that has less wattage, or if you're going to do net back, or if you're going to run a piece of equipment, lower load, what's that savings going to be? It's a 1-for-1 replacement, easy calculation. It's either done on hours or wattage. Pretty easy to come up with. Those were a lot of incentives around those. So it's great if you are able to get some of those done. In fact, go out to client sites. I'm more surprised when we go out there if they've not done these things than if they have, because so many have been done. But one of those things, if you think about them, they really just affect their thing. Lighting is going to affect lighting. You get some heat load break off of it, but really, for the most part, you're just affecting your lighting. You don't really impact the rest of the system. So unless you were able to take some of that savings that was generated and put it back into your facility, you likely still have quite a bit of deferred maintenance facing you out there, and probably really help you from a staffing standpoint. But again, great things to do. So now that you did some of the obvious things, now go for some of those funds. And what we're finding is that maybe some of those savings aren't as obvious. In the past, you used technologies, upgraded technologies, so more efficient lighting, upgraded technologies on drives, or building automation technologies. Those technologies enabled you to be more efficient and do a quick replacement. We're going to kind of that same approach in talking about newer technologies, but in this case, it's going to be using technologies to get the right data to point you in the right direction of where there might be savings at within your portfolio. So this is what I'm showing here. If you look at actually the low chart first, there's a box, VV box that's hunting around. It's trying to hunt around right around, I think, a 50-degree temp there. And when you have a box that's hunting like that, it's causing cycling equipment, you're losing energy, maybe even comfort issues. You can probably hear it in the room where that box is hunting around. So that's an area that you can target for some energy savings. The top chart there is one that I'd like to point out, spend a little bit of time on. Some of you may have seen a chart like this. It's a different chart, and this is a client that we were working with. Some of my team, if they're online, they'll certainly recognize this. But as you look at that demand, those demand levels there in red, you can see that there's peaks there. And even for a utility bill, you could probably say, wow, 50% of our energy cost is going to here. There should be ways we should be able to knock off some of those peaks, and it's great. I have that blue line up there, and that's kind of an arbitrary line of, hey, if we could keep those peaks down below 425, then we're going to save a lot of money. That's a pretty easy calc, and then you're using your technology to determine what level, what load, and what improvements do we need to do to keep us below that 425, and then notify us as we're getting close so we can make sure we monitor the equipment. That's a great savings that likely, if you have demand charges, there may be an area you can target within your portfolio to save some consistent funds and maybe justify some equipment upgrades. What I want to point out here is those two circles at the bottom, that chart there, those are the savings that aren't as obvious. Some of our guys noticed that when we were looking at some of this information. If you've noticed, really, that tells us that some of that equipment that should be setting back and shouldn't be running at certain periods, it's running for some reason. Those areas to target. You can see not even seasonal. Part circle I have is in January, the other one's in July. If you see something running, it's going to be seasonal, but in this case, it's not. So that's a good opportunity for energy savings that without this type of information, you're not going to be able to identify. The second chart that I just put up there, hopefully you can see, that looks at the thermal side. Now it's the same buildings, so the demand chart and then this thermal chart are the same building. And if you notice that each one of those dots are supposed to be full blue, filled in, and you should be hovering around that linear regression line. And so what happens is they start to move away from that linear regression. That gives you an idea of where there might be savings opportunities. And then when they start to go from dark blue to that light block, that tells you that there's an anomaly and something's going on. We can take that information from blocks and compare it to this demand chart. Now, they're two different things. One's thermal, one's electric. But what this told us about the building and gave us direction to was, hey, this building's being overheated, and it's forcing chillers in this other building to run more than they should. That's forcing some of our peaks, as well as maybe some of those evening periods where we have those circles that I noted. Maybe that's what's forcing some of that on. So by combining that set of information together, gave us direction as to where we might target. So keep these two charts in mind, because I'm going to talk back to them in a little bit as I go into a little bit more example on this particular client. But an example of where having newer updated technologies to pull utility and building automation information together, if you can start to collaborate that information together, it's really going to give you some great direction. So what's the new low-hanging fruit? Well, it's take what you have and already make it a little more efficient. So whether it's enhancing the use of your building technologies, whether it's taking a new utility, advanced technology like data analytics or fault detection, which I'm a very big fan of. I think that those things now are items that can really start to help identify and generate more savings. Big fan of what AssetWorks is doing with their programs. Taking those efficiencies and using them for possibly justification of repairs if you don't have the dollars to replace them. If you have the right data, in the past you used to do that calculation on lighting replacement or on the drives, and it was just again back to that calculation of what the wattage was before, what it is later. But now if you can track information and then make a repair and go back, you can actually prove what those savings were before. If you can do it on a couple pieces of equipment, now as you start to move forward throughout your portfolio, you can use that as justification, hopefully to get more funding for some further upgrades and repairs. Another thing you might use that low-hanging fruit for is maybe decreasing the need for added capacity or new equipment. A lot of you out there probably have some type of a central plant, either chilled water or steam or hot water, and you might be thinking, okay, you know, we're getting close to our capacity. We're going to have to add a chiller or add a boiler. Well, maybe if you get out in the spaces and you're able to make them more efficient and dial some things back, maybe you find that maybe you don't need to add more capacity, or if you do, maybe you don't need to add as large of a piece of equipment, which is going to be, you know, a little bit easier for your budget to handle. Another thing I have on here is, you know, right-sizing the needs to personnel levels. So don't get me wrong, when I put that on there, I am not advocating at all decreasing staff. I mean, most on the phone, 99% of you probably have too lean of a staff already. We'll talk about this in more detail, but really it's rather than trying to hire more personnel, which you're probably having difficulty doing, but hire personnel to put out all the fires you have, well, let's try to knock out some of those fires and find a way to bring the needs of your portfolio down to the level of your staff so that it's more manageable. So those are some of the things that we'll talk about here on the low-hanging fruit. So this here shows some of the things that I might be talking about. So I'm not going to go through each of these, but as you notice, as you step through some of these, that a lot of these have to do with heating and cooling at the same time. You know, starting one system fighting the other and forcing one to run more than it needs, or maybe you're just duplicating effort. I'll give a real good example of that here in a second. Others that you'll see here are equipment that you have just not operating properly. Maybe it needs calibrated, or maybe it needs repair. Maybe it's just not being used. We have a number of clients that have drives, low frequency drives on their equipment, and they're just using them for soft starts. We go out and we take more control, and really they're doing that again because they don't have the information. They don't know what should actually be running it at. So we go take control of those. It's a great short, small controls upgrade, quick sequence into the system. You're getting some great savings off your equipment out there. So some of these are more on the equipment replacement side, but some are just repairs and calibration that are going to drive savings so that you can either use those dollars to help ease some of the pressure on your budget, or you divert some of those dollars from the savings and you use them to replace some more equipment, otherwise you wouldn't have a chance to replace. So I go into about 3 examples of areas where we found some of that low-hanging fruit with some clients, and a pretty diverse set of opportunities here that we were involved with. The first one being a commercial office building. 24-hour facility, but there was opportunity for setback there. It's an office and retail site. You know, headers that are running really quite often. I mean, 35% there actually should be temps below 35 degrees. So it was running pretty low, and we were even over there. It was 25, and they were running 30 degree. I don't know where that percentage sign kept coming from. 30 degree chilled water discharge temperature. You know, important areas, but very low control. Very low control. A lot of things manually, and they were just having to override everything. They had very high electric bills. Those 2 charts I showed you earlier, the one that had the demand chart and then the one that had the thermal chart, those are from this building here. So as I mentioned, you know, what I found was that they were overheating the building, and they were forcing chillers to run more than they really needed to. They had a number of firms come in and take a look at it. Most of them were saying it was going to need, you know, $3+ million to come in and address some of the needs. And once we identified that, hey, a lot is being driven by this heating, we were able to identify. We sat down with them and determined where most of their maintenance headaches at. and they have a lot of constant volume boxes out in the space, so we converted the constant volume boxes to VV. Controls upgrade to give them a lot more control. We didn't do any major new equipment, no new chillers, boilers, or anything. Didn't do any lighting. All of it was mainly controls, retrofit in the boxes, and then we put in a plate and frame heat exchanger. And they had tried that in the past and gone away from it. And the reason they had gone away from it was, again, because the heating was driving the load up to a point at which they couldn't utilize the plate and frame. They felt they needed that 38-degree water. So by starting out in the spaces and addressing the boxes and addressing the controls so they could manage that better, and then address on the heating side so that they weren't overheating it, we managed load within the space. And when we managed that load better, that enabled them to direct their chillers a little bit and enable us to utilize that plate and frame a lot more. So they're going to drive significant amount of savings. It's going to be, as I know here, 6.5-year energy only payback on the project. So really it came through getting the right information and going and finding that low-hanging fruit that was existing within their system. And just minor upgrades. Now they're going to have a lot better comfort level, get a great handle around their equipment, and really now be able to maintain the building much better than they were able to do in the past. So it's great for them. The client I have here is a mid-sized hospital, and I'm clear on some of the needs that we might be able to address, as one of them being maybe a capacity issue. That's what this group here is facing. They had a tremendous amount of deferred maintenance, mostly due to funding. Their capital budget was very low, and things had just snowballed from a deferred maintenance standpoint over the years. So they felt that they were under capacity on their chilled water plant. And if any of you were a hospital or know have been involved with healthcare in the past, you know that there are certain spaces within hospitals that have to have much cooler temperatures than others. What they've been doing is running their chillers year-round at temperatures below the freezing level just to get the coolant water out into the spaces. So they're running at a 38-degree chilled water temp discharge. And really, that was for about 4% of their footage. So the operating and surgical areas within the complex, at the 5-building complex, they had operational and surgical areas that are about 4% of the overall square footage, but they were running their entire plant to satisfy the temperature need within that part of the complex. In addition to that, they had lots of steam losses throughout the complex. So again, very cost, felt like they were handcuffed, did feel like they could really go anywhere from an energy saving standpoint. And because of their budget, they were spending so much on utilities, they really didn't have any money for some capital or deferred maintenance improvements. So with them is by getting the correct information on the spaces, identify how much load was really required for those OR and surgical care units. Really, the plant would be able to handle if we took those off. They're another case where they went away from heat exchanger and economizer because they felt the load of the building was requiring more, and the heat exchanger couldn't handle it. So taking the critical care units off of the loop and putting those smaller units, that's decreasing a significant amount of the load. That's going to enable them to run the chilled water temps at a higher level. It's going to enable us to put in a heat exchanger to enable free cooling. So those things in itself are going to drive a significant amount of savings. Additional savings is going to be they're not going to have to add the new chiller. Really, we're thinking about adding a whole new plant because of redundancy. But in this case, they're not going to have to add quite a that. If we do, it'll just be a small chiller, so it's going to be significant capital savings from that standpoint. Other things such as repairing and replacing the steam traps throughout the complex. It's going to be a benefit on the boiler side. They didn't have a capacity, but they were really running ahead of those boilers, so that's going to be quite a bit of savings. They're going to upgrade their building automation, and between automation getting control of the spaces and adding that heat exchanger, we're going to be able to introduce a chiller plant optimization program. So it's really going to extend the life of those chillers. Their chillers aren't too old, only about 16 to 18 years old, but they've been running them at such high levels for such a constant period of time, really ever since they've been put in. Because of that, they're putting a lot of wear and tear on those. So we're open through chiller plant optimization, taking some of that load off. We're going to be able to extend the useful life of some of those chillers. So we haven't done this yet. We're in the midst of developing this. So as for savings percentage, I don't have those at this point. Now it's looking pretty significant. We know that we're going to have savings to help cover those costs. So quite improvement, and it's also going to help reduce a lot of their deferred maintenance out on the spaces. The third grant that I have listed here is it's a public university, and this one is a university up north in the part of the nation, and a number of issues, quite a bit of deferred maintenance, really did not have a good handle on their equipment inventory, especially their asset condition. They're doing deferred maintenance, but really not in the right manners. Their deferred maintenance was piling up, so they were doing preventive maintenance, not taking care of much of the deferred maintenance. Still had a tremendous amount of work orders coming through, a tremendous amount of issues. They were kind of throwing their hands up in the air, and they're feeling their staff and their administration were at odds because their staff felt they needed more power, and they weren't able to address the issues that were being put up for them. And the universities kept building buildings that hadn't square footage, so that wasn't helping the issue. But the university itself had bills, and the rates were going up every year, 5 to 6%. Full building automation systems throughout the campus, all with poor calibration, many different vintages. A number of them, they didn't talk to each other, so they had very sporadic control across the entire campus. It's about a 1,000-student campus, about 4.5 million square feet. I think they had 45 buildings, I think. I think a number of pumps and motors going bad. Again, it gets back to that preventive maintenance thing. They felt they were changing filters and doing maintenance on their, punching tubes, but their pumps and motors and the distribution system was about shot. They had 2 HVAC staff members, so two staff members who were focused on HVAC, and then they had a lot of trades personnel, plumbers, electricians, mechanics, carpenters, things like that. So really 2 main HVAC guys, and then the others would come and help as they had opportunity. Again, a little understanding of their systems on their campus or condition. Really needed a better handle on their work order system. They were getting away from them. They weren't managing that very well. But as from a work order standpoint, they had a lot of work orders that were coming in, and what we found is that some were just left open, and some of them were just noted that they were being addressed when in reality they really weren't. That university had a lot to deal with. So we came in, we sat down with them and really prioritized what their needs were, and we come up into 3 specific areas. We came and said, okay, let's look at your energy cost per square foot, and so we looked at that, prioritized the buildings by that standpoint, and then wanted their automation and all to be consistent, standardized throughout. So we went through and we noted all the vintages and types of automation throughout their campus. And then we just sat down with the staff and we said, okay, stack rank what you feel your biggest challenges are from worst to least as far as buildings. And we had them rank all those 1 through 40. And then with those, and we kind of weighted each one, and we came up with a priority list, and we broke it up into 4 phases. And we said, now let's go out and let's get the data that we need to back this information up, build a baseline. And so when we started to do that, some things really started to stick out to us as far as what some of their needs were. And really what they thought were some of their biggest energy consumers and were some of their worst conditioned buildings were inaccurate. And we reprioritized that list And we worked with them on an energy and deferred maintenance program. So as we went out, we took, we looked at their building automation system and trends as much as we could. And then we looked at their utilities, and we went out and we actually took measurements, vibration analysis on certain equipment, and put loggers throughout. They didn't have the utility and building automation information that you really needed for that baseline. So we manually took those things and helped them build an energy and deferred maintenance program. Then we built a 5-year capital plan. And doing that, saved them 24% of their energy. We turned back in to fund out of those major upgrades. And so it could be funded through energy, we put in one bucket, and the things that could be partially funded, we kind of separated out, and some of those we did, some of them we put in the capital plan, and the things that was capital upgrades, we put out with the administration and the board that, hey, if we take care of this much without having to request funds, can you give us funds to address this much? We made a deal. Once we and the facility staff took care of our end, then the board took their end, and they freed some capital that we helped them budget out over a 5-year period, and they started to address some of those items. Then we added in a key component of it was the agreement that we made with the board was that we're going to put in these technologies for the analytics and continuous commissioning, and we're going to train the staff. So we stayed on for a year where we handled a lot of the preventive maintenance items and spent half of the time working with them on analytics and building automation system. So we trained their staff so that they knew how to maintain the system. The commitment of the board was, if you invest this, we will help your staff get to a point at which they will be able to maintain it at that level. And so and it worked out great. So after about a 2.5-year period of going through this, of a number of different phases, we looked back and we reduced their work orders by 60%. Significant amount of reduction, and I'll tell you the truth, I think it was even more than that. The reason we tabbed it at 60% is because that's really what we could quantify. As I mentioned earlier, they really didn't have a good handle on their work order management system. I think it was really even more than 60%, but it was a significant impact. And 24% of their energy costs were saved and reached back into funds. So this little chart here maybe to kind of give you a visual on that particular concept. So if you look at that blue block and say, okay, that's the level of our staff right now from a personnel standpoint. The red block is maybe our portfolio needs. What do we need across our campus or our healthcare complex, whatever it is. And those blocks, you can make them. They can be dollars. They can be work orders. They can be, FTE or man hours, whatever you want to make them. But some type of metric that says this is the level of our staff and this is our portfolio needs. A lot of times, and where administration and staff get kind of butted at is that the staff is saying we need more personnel, and administration is saying, well, we don't have funding. Do what you can. You should be able to handle it. And so there becomes an issue. So going back to that university and how we help them address it is we said, okay, what are the portfolio needs out there? Let's right size those down to your staff level. So the thing we addressed was energy conservation, 24% that we talked about. So we took that 24%. We took care of a number of deferred maintenance items that they had. We took care of capital items that they had. And what we couldn't do, we planned for. We helped them build a plan. The next thing we did is we put in the advanced technologies, enable them to do more with less. I've seen numbers in the past from a maintenance standpoint that on average it takes 4 hours to go out and address a maintenance issue because you have to do what you're doing, you have to go out there, you have to have the right equipment, you have to know, so you have to go back, get what you need, and then you have to come back and address it. What if you address that through advanced technologies, either catch it before it comes out, or before you go out there, help from a data analytics or fault detection standpoint actually tell you the diagnosis before you get out there. That's going to cut your time in a half or a third. So enable you to cover a lot more. What a lot of, in this case, what this university staff used to have to do, they used to have to run out, and they'd have to go check it out. And half the time it'd be nothing, and half the time they'd have to back and address it. this way, what we found is they're able to, from either pad or from neutral location, identify and help diagnose what the issue was, and they might prioritize it. They may not even go over there. They may say, okay, we're going to come over tomorrow and address it. Or they may know what it is, and they may be able to send one of their junior guys over there to address it. So it saves a lot of time from the advanced tech, from the just the maintenance standpoint. And the repairs. So as I mentioned, we not only did the deferred maintenance and the capital improvements, but we helped set up a repair program, and we let all those things out, what the cost was going to be, and we determined what could they do on their side and what could we do on their side. We did part of it, and then we gave some of the other items for them to address, whatever they felt they could handle. If it got to a 60-day point where they couldn't handle it, then we'd take care of it. But we addressed those repairs. So now we get to a point where now that new level of staff that's needed is that yellow block. So you're much closer to what your level of staff is than what you were before. You're still short. At least it's more manageable. And now at that point, you look and you say, okay, what did we save? So we saved about 10% on energy conservation, 3% on the advanced technologies, 5% on repairs. Maybe now that you have those advanced technologies and you're able to have improvement what the heck was on what you did before, and now you're tracking and you can quantify what's going on out in your spaces, maybe you can say, hey, you know what, I think we can save 3% by adding more staff because we can manage these things better and we can manage our deferred maintenance. And maybe that's justification, maybe not, but it's something to think about. And if you've done those 3 green boxes at the top, you've already proven yourself. So maybe the opportunity to do that. So those are up, and those are 21%. The 10, 3, and 5, those come from Berkeley National Labs. Everybody has studies on what they think an average is for reductions. Energy conservation, I oftentimes see much higher than that on the 10%. I'm sure a lot of you do as well. But advanced technologies, 3 to 5 repairs, 5 to 7. That's kind of what you see there. But those are just examples. So that's what I was talking about as far as maybe bringing the requirement of your portfolio down to the level of your staff. So in closing, again, the low-hanging fruit items, the old ones, the lighting and drives and whatnot, those are great things to do, and hopefully you were able to do them. Hopefully you got some incentives out of them. That's great. But now the new low-hanging fruits, now equipment replacement, in my mind, I think from what we've seen in the past, is actually more lucrative. If you get the right technologies, the right information to help you make those more informed decisions, there's likely a lot of money within your existing portfolio that you can now quantify and move forward with. I know that a lot of you have a good understanding of what you need to do in your spaces. You just need the justification to do it. Again, that information is what helps bring forth that new low-hanging fruit. So, I'm a big advocate of starting out in the spaces, where the distribution is, and start working your way back to the source. Start working your way back to the plant. Gather as much information you can, and really try to determine what's your true load, what are your true total costs of operations for your facilities. Target those things and drive them down. So those things that justify either that new equipment or just ease some of the pressure on your energy budget, help you from that maintenance and repair side. As I have listed here, if you know what ASHRAE says, that preventive maintenance is the #1 savings item that you can do throughout your portfolio. And so, again, appreciate your time. I've seen a lot of clients have success with this, and hopefully some of the things that I talked about today regarding the new low-hanging fruit are some value. And I think Sean's going to open it up for any questions.
Yeah, thanks, Chad. Yeah, we're going to open the floor up now for questions. If you'd like to put a question to Chad, you can do so by typing your question into the Q&A box and submitting it to us. We'll hold on the line here for the next couple of minutes just to see if we get any questions. So we urge you to go ahead and ask Chad if you have any questions. still chat.
Right here, Sean shows my number and email address. If anybody has any questions afterwards, they can always shoot me an email or give me a call.
Absolutely. Well, seeing no questions coming in right now, I guess we'll go ahead and close for the day. We certainly thank everyone for joining us today on today's webcast. If you'd like more information about AssetWorks solutions and our energy management suite, you can get the information on our website at www.assetworks.com. And we invite you to join us again in a couple of weeks as we have a second in our EMS webinar series I believe it's March 12th at the same time, 1 o'clock Central, 2 o'clock Eastern. And we thank you again, and